Okay, I'm gonna try and crank out the solutions here real quick. They need to use this room in about 30 minutes. So see how much I can get done. 30 minutes. And I'm working 8/6 double angle and half angle formulas. Number 7, they just want you to recognize a formula, so I'm not going to do that one. Number 9, we're given sine theta. It's 3/5. Make sure I'm recording. My microphone is on. I have an incoming call. I'm going to reject it. Okay. Theta is between 0 and pi over 2. And we're being asked for sine 2 theta, cosine 2 theta, sine theta over 2, and cosine of theta over 2. All right, so to do these, we're going to use all the formulas that we got in class, but all we have is information about sine of theta. So I'm going to construct a triangle to work off of here. And my angle is between 0 and pi over 2, so I'm in the first quadrant. Draw a triangle. Here's theta. And sine of theta is opposite over hypotenuse. So this is opposite, this is hypotenuse. 3 is positive because I'm in the first quadrant. I also know that this side is going to be positive. This is a 3, 4, 5 triangle, a Pythagorean triple, like mentioned in class. So I've got everything I need for that. And now I'll just jot down what cosine theta is. That should be 4/5 adjacent over hypotenuse. So I can come up with all of these now with this information. So sine of 2 theta, the formula is 2 sine theta cosine theta, which is 2 times sine theta, which is 3/5, times cosine theta, which is 4/5. And if we multiply this all together, we get 24 25ths. Okay, cosine of 2 theta, I can use any of the formulas that I want for this. Which one? I'm going to use this one, cosine squared theta minus sine squared theta. So if I take cosine theta, which is this, and square it, and then subtract sine theta, which is this, square that, I'm going to get 16 25ths minus 9 25ths, which is 7 25ths. And then sine of theta over 2 is plus or minus square root of 1 minus cosine theta over 2. So this is plus or minus the square root of 1 minus cosine theta, which is 4/5, over 2, which is plus or minus square root of, see, 1 minus 4/5 is 1/5, and then divide that by 2, I get 1/10. And I can leave it like that. The book's probably going to split this up into 2 roots, like that, and probably put plus or minus 1 over root 10, and then they'll probably rationalize the denominator, or rationalize things, but I'm going to leave it. I just need to figure out if it's plus or minus. So I go to this original expression here, the restrictions on theta, and I just divide everything by 2. So that becomes that theta over 2 is between pi over 4, and 0 divided by 2 is still 0. So that means that my theta over 2 is between 0 and pi over 4. We're somewhere in here. So I know that both cosine and sine are positive here. So I want to know what sine of theta over 2 is. That's the y coordinate, so it must be the positive answer. So it's positive 1 over root 10. Now cosine theta over 2, again, my answer is going to be positive because I'm in the first quadrant. So the x coordinate is positive, but the formula changes here. We have a plus here instead of a minus. And so I'm adding 4/5 over 2. So this is going to be, I'll go ahead and say it's the plus. I already know that. Square root of 1 plus 4/5 is 9/5. Then divide that by 2, you get 9/10. And so this is just root 9 over root 10, which is 3 over root 10. You could also rationalize that. Okay, I went fast through that, but that is it. Okay, let's look at number 11. Tangent theta is 4/3. And we're given that theta lives between pi and 3 pi over 2. And we have the same 4 questions to answer. I'm going to draw a new triangle. I'm going to figure out what quadrant I'm in. So they give me I'm between pi and 3 pi over 2. So I'm in the 3rd quadrant. Draw my little reference triangle here. And I know that tangent, which is opposite over opposite over adjacent, or y over x, should be 4 and then 3, but because I'm in the 3rd quadrant, these must both be negative because I go over to the left 3 and down 4. Now this side over here is 5. I can do the Pythagorean to get that. So I've got that, and remember the hypotenuse is always positive. So from this I know that sine theta is the opposite over hypotenuse, which is negative 4/5. I know that cosine of theta is the adjacent over hypotenuse, so negative 3/5. And then I just come into the formula, 2 times sine theta times cosine theta. Okay, I'm not even going to work this out because of time. So that would be the answer for that. For cosine 2 theta, I'll use that formula again, cosine squared theta minus sine squared theta. So I'm going to take cosine theta squared minus sine theta, which was negative 4/5 squared. That's 9/25 minus 16/25, and that's negative 7/25. All right, that's it for that. Now I need to figure out where theta over 2 lives. So I divide this by 2, divide that by 2, divide this by 2, which makes that 3 pi over 4. So that means theta over 2 lives between pi over 2, which is straight up, and 3 pi over 4, which is about right there. So we are in the 2nd quadrant. Theta over 2 is in the 2nd quadrant, which means our cosine is going to be negative and our sine is going to be positive. So let's keep that in mind. Our cosine is going to be negative and our sine is going to be positive. So when I do the formula, it's going to be square root. It was plus or minus, but I'm going to use the plus. 1 minus cosine theta, which is this, negative 3/5 over 2, which is square root of 1 plus 3/5 over 2, and that's square root of, let's see if we add those together, we get 8/5. Then divide by 2, we get 8/10. And that reduces to be square root of 4/5. And you could rationalize after you do the root on the top and bottom, you get 2 over root 5, and then rationalize. Okay, for this one, I'm going to get a negative answer. So it's the negative root, and then it's 1 this time plus negative 3/5 over 2. This is minus, let's see, this is 1, take away 3/5, that's 2/5, but then divide by 2, so 2/10. So negative root 1/5, which is negative 1 over root 5, just taking root on top and bottom. That's it. Okay, number 17, cotangent is negative 2. And my angle is, oh, it doesn't give me an angle, it tells me that secant theta is negative. All right. So let's try and figure out what quadrant we're in. So we can draw our little triangle. So I've got cotangent being negative. Since cotangent is the reciprocal of tangent, it's just tangent flipped over, this means that tangent would also be negative, and tangent is only negative here and here. So we cannot be here, we cannot be here. And then secant being less than 0 means that secant is negative. Secant is the reciprocal of cosine, so this means cosine is negative. Cosine can only be negative over here on this side, so we've got to be up here, so I can eliminate this one. So we are in the second quadrant. Cotangent being the reciprocal of tangent means that this is, instead of opposite over adjacent, this is adjacent over opposite. So I can do something like -2 over 1. So just writing that as a fraction, this is going to be adjacent over opposite. And I put the negative here and the positive here because I moved to the left, so that's -2 and up 1. Notice that if I put this negative and that positive, we would still get -2, but it wouldn't match up. This is not to the left 2. So I have to put the negative on this one and the positive there. And then we can get this side, Pythagorean. This is √5. So it's this squared plus this squared. Take the square root. And now I can just write everything down that I need. I know sine theta is opposite over hypotenuse, so 1 over √5. And cosine theta is adjacent over hypotenuse, so -2 over √5. And should I do this? Man, time. I think I did enough of these in class. I mean, all you need is these two, and then you can figure out what these are. So maybe you'll have some questions on these. Oh, well, let me figure out where at least what quadrant those will be in. So if I'm here, if I'm in the second quadrant, then that meant that my original theta was between pi over 2 and pi. That was where I had to be, pi over 2 to pi. So if I divide this by 2, divide this by 2, and divide this by 2, this becomes 4. So that means that my theta over 2 lies between pi over 4 and pi over 2, which is straight up, so somewhere in here. That means both the y-coordinate and the x-coordinate are both positive. So when I do these and do the plus or minus on the roots, I'm going to do the pluses on both of them. And then I'll let you go ahead and plug things in yourself. Okay, for 19, I will just set up, I think I'm just going to set up the triangle on 19. 19, tangent theta is -3. And sine theta is negative. Okay, so tangent being negative means that we are in this one or this, oh, sorry, oops, wrong one. Tangent being negative means we can't be there or there. And sine being negative means your y-coordinate is negative, so you got to come down like this, so we're not here. And tangent is opposite over adjacent. So I'm looking at -3 as being -3 over 1. And yes, the -3 needs to go here because we went down 3, and then to the right 1 is +1. So this should match up with that information. You can get this side by the Pythagorean. This should be √10. And now you have everything you need in order to determine all of these. Now, to come up with the signs on these, I just need to figure out where theta over 2 is. So keep in mind that our original theta is between here and here. So our original theta is between 3 pi over 2 and 2 pi. So if I divide everything by 2, this will become a 4. And then this 2's cancels, so you get 3 pi over 4 less than theta over 2 less than pi. So where is that? So pi is here, 3 pi over 4 is here, so we're somewhere in the second quadrant, which means that the x-coordinate's negative, cosine is the x-coordinate, so that's negative, but the y-coordinate is positive, so that means we'll take the plus on this one. And then just plug into the formulas. You'll plug in both sine theta and cosine theta. Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. So So we should just use those and plug them into the formulas and we'll be good to go. I feel like I'm in a mad rush here, but I am. Told me I only have a little bit of time in this room, so. Okay, moving on. Number 21, find the exact value of sine of 22.5 degrees. And it says use the half angle formula. So what we need to realize here is that 22.5 is actually 45 degrees divided by 2. So using the formula sine of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 2. We know that theta here is 45 degrees. So this becomes plus or minus 1 minus cosine of 45 degrees over 2. Now cosine of 45 degrees, here's 45. On the unit circle, cosine as the x-coordinate is root 2 over 2. So we know that this is root 2 over 2. So we get plus or minus square root of 1 minus root 2 over 2 over 2. And then I'll continue this. This is equal to plus or minus square root. Here I get a common denominator, so I'll put 2 on the bottom, 2 on the top here, and then I'll do 2 minus root 2 over the common denominator, but then all of that over 2. And then this really becomes like this, and I can flip it up like that. So the 1 goes on top, the 2 goes on the bottom. And then I'll just distribute across. So plus or minus square root of 1 times the top is just 2 root 2. 2 minus root 2 over 2 times 2 is 4. And I guess we could do one more thing here. Plus or minus, I could split this into 2 roots. Do the root of the top. And then the root of the bottom, the root of square root of 4 is 2. So I could probably leave it like that. Now let's figure out if it's plus or minus. Now this is actually kind of easy because we actually know what the angle is. This is theta over 2 right here. That's theta over 2. That's 22 degrees, so we're in the first quadrant. If we're in the first quadrant, then both the x and the y coordinate is positive. So sine is the y coordinate, it would be the positive case. Hello? Okay. I should know better than to answer my phone. All right, let's look at another one of these. 23. Tangent of 7 pi over 8. So I'd like to see if I can look at that as a common formula. Or a common angle, I should say. This is the same as tangent of 7 pi over 4 over 2. So I noticed that in order to get that 8, what I could do is take 4 and divide it by 2 so it would reciprocate up and you would get the 7 pi over 8. So you kind of have to see that to do this. Now, do we have a formula for this? Well, we do. I'm actually going to pull the exact formula. We didn't talk about the formula in class, but there is a formula for half angle for tangent. It's just easier if I use the formula here. Here we go. I'm using the formula off page 661. So tangent, they use alpha, that's fine, equals sine alpha over 1 plus cosine alpha. Very clean formula for theta over alpha over 2, sorry. So tangent of alpha over 2 is sine of alpha plus 1 over 1 plus cosine alpha. So for us, the alpha is 7 pi over 4. So this is going to become sine of 7 pi over 4 over 1 plus cosine of 7 pi over 4. And so where is 7 pi over 4? Well, here's pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So here's where we are. And what I need is the sine and the cosine. So off my circle, remember this is root 2 over 2, negative root 2 over 2. So sine of 7 pi over 4 is the y-coordinate, negative root 2 over 2, over 1 plus cosine of 7 pi over 4, which is positive root 2 over 2. And they probably get common denominators, but I'm going to leave it like that. I would take that on a test. Okay, for number 25, I have cosine of 165. So let's try and use a half angle. So this is equal to cosine of something over 2. So what is that? 300. This should be a common angle. 330. Is that right? 330. 330 degrees divided by 2 goes in there 1, 6, 1, 0, 5. Yes. Okay, so that's the same as that. And 330 degrees on our unit circle is right here, like this, and that has the coordinates root 3 over 2 and 1/2. So the formula for this is plus or minus square root of 1 plus cosine of the angle, which is 330, over 2. So this is plus or minus square root of, let's see, cosine is the x-coordinate, so this is 1 plus root 3 over 2, then all of that over 2. And the only thing left to do, I mean, we could clean this up, but figure out if it's plus or minus. So where is the angle, and this is important, where is the angle 165? The angle 165 is actually over here in the second quadrant, right? We're going to be over here. And so cosine is the x-coordinate, and the x-coordinate over there has got to be negative. So we are going to be taking the negative answer here. Be careful, you're not looking at 330, okay? We're looking at cosine of 165. We use this to be able to get the answer off using one of our common angles, but the actual determination of whether or not it's plus or minus comes from going back and looking at 165 and seeing where it is. All right, I think for 29, I'm not going to work it out, but for 29, just look at that as being sine of negative pi over 4 over 2. So your angle here is negative pi over 4. Right there, and that's going to be positive root 2 over 2, and then negative root 2 over 2. And then you use your plus or minus formula for this, but it'll have a minus here instead. And really just, is it positive or negative is really the question. And so you have to figure out where the original angle was, and the original angle was negative pi over 8. Negative pi over 8 is going to be down a little bit, like this. And that means the y-coordinate, because we're looking at sine, is going to be negative. So when you get to that plus or minus, we're going to be doing the minus, not the plus. Okay. I think that's good, hopefully. I'm so sorry I'm rushing through this, but I want to have answers. Number 31, I'm going to skip because I'm not going to test you on that, and I also gave you an example of that in class. Number 47. Number 47. This one's interesting. I did not talk about this in class. We have sine of 5 theta. So it says to take the expression sine of 5 theta, and it says write it as a 5th degree polynomial in the variable of sine 5 theta, or sine theta, sorry. So they want us to somehow convert this into an expression where we get something in here with sine theta, but to the 5th power. Somehow, some way, we can change that from sine of 5 theta into this. So here's how I'm going to do this. I have a power reducing formula, I should say a half angle formula that allows me to, I'm not saying half angle, double angle formula that allows me to rewrite things that look like this. Let me just write this down. How about this? Do we agree that that's that? It is, right? 4 theta plus theta is 5 theta. Now, according to the sum difference formula, this is sine of 4 theta sine of theta, cosine of theta, oops. And then I have plus sine of theta cosine of 4 theta. Okay, so that's just using the sum formula for sine. Now what I'm going to do is I'm going to use a formula for, let's look at sine of 4 theta. Sine of 4 theta, I'll do this on the side. Sine of 4 theta is the same as sine of 2 times 2 theta. Okay, so this is like a double angle formula. It's sine of 2 times an angle, which is equal to 2 times sine of the angle is 2 theta, times cosine of the angle, like that. That's kind of tricky, but that's what this is. All right, and then I'm going to go even further, even though it's going to be a little messy, but now I'm going to take this and use the double angle formula for that, which means 2 sine theta cosine theta. Nasty. And then this one, I'm going to use the double angle formula for cosine, but I'm going to do the one that has the sine in it. So this is 1 minus 2 sine squared theta. Okay, so I use double angle formula here to get from here to here. The 2 came for the ride. This cosine 2 theta, I use a double angle formula. So notice that what I've got in here is a bunch of stuff that has sine theta, and then I have a cosine theta. Now this was all this. So that's just this part right here. Gosh, what a mess. So let me put this together. I have 4 sine theta. I'm going to move this one next to it. 1 minus 2 sine squared theta. Then I had a cosine theta, but I have another cosine theta here, so it's cosine squared theta. Okay, plus sine theta, that's this one. And now I need to figure out what cosine of 4 theta is. So I'm going to kind of do the same thing I did here. Cosine of 4 theta is equal to cosine of 2 times 2 theta. And then I'm going to use the double angle formula that has sine in it. So this is 1 minus 2 sine squared of 2 theta. Notice it's 2 theta here because that's the angle that's being doubled. And then from there, I'm going to rewrite this as sine of 2 theta, but then squared. I'm just rewriting what this means. Sine squared 2 theta really means this. And then that's equal to 2. This right here turns into 2 sine theta cosine theta, double angle formula for sine, but then squared. I'll be right there. Oh, wow, I'm out of time. 1 minus 2 times, I'm going to square the 2, I get 4. Square the sine, I get sine squared theta. Square the cosine, I get cosine squared theta. Okay, and that can become an 8. So I'm going to have this sine theta and then times all of this, and then I'll distribute you, but I'm out of time. They're kicking me out of this room. What other homework is there? Yeah, there's still more to do. Dang it. Oh well, I tried.